Here at Extreme Endeavors, we have developed the concept of a digital twin for our automation and control system. A digital twin is a virtual representation of a real-world system. It is a graphical user interface that is fully explorable 3D scene. Depending on the level of complexity, it is also controllable. A digital twin is useful for visualizing a system for both planning and operational purposes. Digital twins can be very large, such as representing an entire city, to very small, such as representation of a mechanical object like a water pump. One challenge for exposing complex systems to users for exploration is the sheer size of the scene and the many objects that it contains. To make navigation easier, we have developed the concept of layers, as you can see here on the right side of the screen. Layers represent an operational organization of parts of the system. Because digital twins can often represent a collection of different systems, these layers can help the user focus on just the level of detail that they are interested in. In this digital twin, we are showing the operational systems for a small city's water production and distribution. When I select the water production digital twin layer, the camera zooms to the location of the city's water production facilities. If you look at the panel below the Layers panel, you will see the Sublayers panel. This panel provides more detailed information and options for the selected layer. To aid in quickly navigating to different parts within the digital twin, there is a section called Points of Interest. Selecting a point of interest will quickly move the camera to that particular target. I'm going to select the raw water intake point of interest. As you can see, the camera moved to that small building. Targets can more easily be seen by making certain features transparent, such as walls or other obstructions. This allows the user to see into the building much easier. The user is not constrained to jumping around the scene using points of interest. The user has full control of the camera and navigate to specific areas within the scene. There are also visual indicators that can be used to signal different statuses for parts of the system. For example, if a pump needs maintenance, it can be highlighted with a specific color and tagged with an icon to call attention to its status. We've also developed the concept of the beam from heaven. The idea is that for very large scenes, you may need to be able to quickly identify places of interest. These beams from heaven can be seen from just about any vantage point and can be used to highlight areas that demand the user's attention. Let's quickly navigate back to the Flash building to take a peek at the layout and equipment inside this building. We can also navigate through the rest of the building to see the flow of water through this system. Water is pumped from the river at the raw water intake and treated with chemicals in the flash building. It flows through the settling basins and into the water plant, where it is filtered. It is then pumped to water tanks for storage and distribution. Along with visualizing the objects within the digital twin, information can also be provided. For example, if I select the twin tank's point of interest and zoom to that location, the system will display the relevant information for that site. I can view a real-time graph of data. I can see some operational parameters. I can even view documentation for equipment at that location. I can also zoom in to the equipment at that location. I can select the box that has our electronics installed in it and make the front cover transparent. I can also select the object that represents our single node and click it and see some configuration documentation for that particular device. I can click again and close the cover. And there is our beam from heaven. We can also look at the water distribution side of their systems. As you can see, there are many points of interest in this particular part of their system. But let's just zoom into their valve station. When I zoom into the valve station, it shows me a detailed view of information at that site. I can see the input pressure and the output pressure. I have the ability to turn that valve on and off, as well as look at a graph for past data. I can also navigate through this building. I can see the equipment at the top floor. I can see the equipment in the basement. Let me show you another digital twin. This is a much smaller system and represents a single sewer lift station. I can navigate to different parts of the system and see the overall layout. If more equipment needed to be added at this site, I could plan for where the new installation will need to be placed. Just like the other system, there are points of interest where I can zoom to those locations. And I can see more detailed information. And I can see the overall status of the system, see the layout of the electronics as they're installed at this lift station. When it comes to digital twin representations of real-world systems, there is no limitation to how simple or complex that virtual representation can be. It can be fully customized to provide the best visualization, operational control, and management for the system.